everyone, and welcome to 5.2, which concerns the uniform distribution. Okay, which is, the easiest of the distributions. Okay, so the function for the uniform distribution, I think we talked about this before. It's a 1 over b minus a. So basically, it's a constant fraction, and b being the largest and a being the smallest value in the interval for x. Okay. Okay, so the theoretical mean and standard deviation are over here, so it's just the average, right? Of the lowest value, the highest value divided by 2, that's the mean, mu. And the standard deviation is the square root of the quantity b minus a squared over 12. Okay, now we can derive this with calculus, but you don't need to do them here. Thankfully, I don't have to bore you with that. So here's a notation. So you would do like x tilde capital U parenthesis a b, and then that's a way of saying x is a random variable uniformly distributed over a b, where a is the lowest and b is the highest. Okay, so the probability of x between c and d, or x between c and d non-inclusive versus this is inclusive and this is not, is just the height, which is f of x, and then the base, which is d minus c. And it's going to make more sense as we go along. Okay, so let's take a super fun example. So let's say you have, here's the data. It's a number of passengers on 35 different boats. So here's the sample mean and the sample standard deviation. They follow a uniform distribution where all values between, including 0 and 14, are equally likely. So what's A, what's B? Let's write the distribution in proper notation, and then let's calculate the theoretical mean and standard deviation. So A is 0, B is 14. So then you would say X is uniformly distributed from 0 to 14. The mean is 7 passengers because it's 0 plus 14 divided by 2. And the standard deviation is square root of, here it is. So yeah, so here it's the square root of 14 minus 0 squared over 12. So that's 4.04. Let's do another one. Let's say you have a distribution given as x is uniformly distributed from 0 to 20. What is the probability of x being between 2 and 18? Now, notice this is the lowest, this is the highest, right? So that'll give us our f of x. Here's the notation, u0, 20, f of x is 1 over b minus a. So, and then also remember that the probability is either, it's f of x times the difference of the endpoints of whatever it is you're trying to find. So f of x will be 1 over 20, because 20 minus 0 is 20. And the probability is going to be 1/20th, so that's f of x. And then d minus c, meaning the interval that you're finding the probability of. So 18 minus 2, so it's just 16 over 20, which is 0.8. Now to find the 90th percentile, you're basically trying to find what's the probability between D and C and D. I mean, we know the probability between C and D is going to be 90, right? You kind of have to work backwards a little bit. Now, we know that, let's say we let C be 0, and we try to find D. That's going to give us the 90th percentile. So, 0.90 is the percent. F of x is still 1 over 20, and D minus C, D is the unknown, so D minus 0. And then we solve for D, right, by multiplying here both sides by 20, and then you get 18. So the 90th percentile will be 18. Okay, now let's do another example. All right, so we have here 55 smiling times. Let's assume the smiling times follow a uniform distribution between 0 and 23, inclusive. Okay, so then that's, let x be any smiling time in that interval is equally likely. So the notation would be, we need to find the notation, and we need to find the let's say we'll have to find the mean and the standard deviation. Again, remember the probability density function is defined as 1 over b minus a, where a is the lowest, b is the highest, and here's the formulas for theoretical mean and standard deviation. So what would be the notation for uniform distribution, the probability density function? Okay, so here's the hint, is that here basically is what you need to do. Now remember, in this case, A was considered to be 0 and B was considered to be 23. And that was given to us in the problem on the previous slide. So that's why we have here 1 over 23 is the f of x, because B is 23 and A is 0. So for this problem, what are the mean and the standard deviation? So basically you take A and B and you just plug them into these two equations. Nothing crazy, you can do this. Okay, so your mean is just a 0 plus 23 divided by 2, which is 11.50, and your standard deviation is the square root of, and then in parentheses, b minus a, so 23 minus 0, squared over 12, and then you take the square root of all that, and that's 6.64. Let me go back to that. Sorry. That was a mistake. Okay, so 18 minus 2 is 16, times the height, which is 123, and that's 1 over 23, and so that's 16 over 23, because 16 times 1 over 23 is 16 over 23. And then to find the 90th percentile, basically it's the percentile where x less than k is equal to 90% of the total area. So the picture to accompany that would look like this. So you have your rectangle. So here's your rectangle. Your height, we already determined that that's f of x, that's 1 over 23, the straight line right here. We want to know, what is this value k such that all the area to the left of this, all the way up to 0, is 90% of the total, okay? So basically, base times height is going to be area for this rectangle, the shaded purple one. And we want to know, what is the value of k, so that k times 1 over 23 is equal to 90. Okay, so in this case, we have k over 23 is equal to 90. To solve for k, we multiply by 23 both sides. So then we get isolate k. So k is equal to 0.90 times 23, which is 20.7. So we would say the 90th percentile is 20.7. Okay, so let's find the probability that a random 8-week-old baby smiles more than 12 seconds, knowing that the baby smiles more. That could be kind of confusing, right? But here's the thing. You have to understand when it says knowing or it says given, that means that this question is a conditional, okay? So basically you're saying you're asked to find the probability that an 8-week-old baby smiles more than 12 seconds when you already know the baby has smiled more than 8 seconds. So there's two ways to do this. This way, the first way is my favorite, where we write a new function because the conditional tells us that the sample space has been reduced, okay? So instead of doing from 0 to 23, we go from 23 minus 8, because we know that at least, you know how it's, the minimum is usually 0, but in this case we know that it's more than 8 seconds, so 8 becomes our lower bound, right? So 23 minus 8 will be 1 over 15. So your new f of x is really 1 over 15, and then everything else kind of stays the same, except that now look, your rectangle shifted over, and it goes from 8 to 23 now, okay? So before it was 0 to 23, now it's 8 to 23, so that changes this one to 1 over 15. And now we find our probability. Our probability is that it's greater than 12. So we just go ahead and we draw here the line 12, and we want, remember, probability equals area. We want the area underneath the curve, in other words, the area of this rectangle, going from 12 to 23, so with a base of 11 and a height of 1 over 15. Well, 11 times 1 over 15 today is just 11 over 15, so we're good. Okay, so that's this one. This one's using the concept that conditionals change our sample space. And then the second way to do it is using Bayes' law, where you have the conditional is equal to the intersection over the probability of the condition. Okay, so in this case, The event A is that x is greater than 12, and event B is that x is greater than 8. So we want to find the probability that x is greater than 12 given that, or with the condition that x is greater than 8. So what we're really trying to do is find the probability of x is greater than 12 and x is greater than 8 over the probability that x is greater than 8. Well, these two, what's the intersection of these two? It's just the probability that x is greater than 12, okay? So the probability of x being greater than 12 is 11 out of 23 when you use this graph. And then the probability that x is greater than 8 is 15 out of 23. So we're dividing 11 over 23 by 15 over 23, which gives us 11 over 15. Okay, so... So what was I going to say? 11 over 15. That's basically, I'm not exactly sure. This isn't the correct picture, so I apologize. I thought I put in the right graphic, but just for the graphic here, just use this. Because I guess the correct graphic would be two of these on top of each other, which is kind of confusing. So maybe we just, look at that one. All right, so let's do another equation. Let's do another problem, okay? This is the kind of problem you'll find in Newton, I believe. Okay, so the amount of time in minutes that a person must wait for a bus is uniformly distributed between 0 and 15 minutes inclusive, meaning that's our endpoints. So right away, from just this, let's read this problem, right? I should already know, okay, uniformly distributed, that's already the hint to use, like, this is going to be a rectangle problem, however you want to think of it. But because it's between 0 and 15, I already know A equals 0 and B is going to equal, you guessed it, 15. Okay, lowest value, highest value. Okay, fine. Now, what's the probability that a person waits fewer than 12.5 minutes? So what that is, so first we need to do our density function. What's our density function? Is f of x is equal to 1 over b minus a. Well, b is 15, a is 0. So that's 1 over 15. So we want to know that what's the probability that person waits fewer, okay, fewer than, that's a less than 12.5. So that's just base times height. Here's the picture. We know that our density function, f of x, in other words, this line up here, is just going to be at 1 over 15, okay? And we know that it goes, we're looking for fewer than 12.5. So here's 12.5. We want all the area to the left, fewer than, okay? So my base is 12.5. My height is 1 over 15. And so the probability that a person waits less than 12.5 minutes is 0.83333. Okay, so on the average, how long must a person wait? So find the mean and the standard deviation. So the mean is the average. So, lowest value plus highest value. So A plus B over 2. Oh, that's funny, we put 15 plus 0. So yeah, it's fine. It's not, this is A and this is B, but still you get the same thing anyway, which is 17.5. And then here, B minus A over 12. So that's B minus A squared, don't forget the squared. So 15 minus 0 squared over 12, so that's 225 divided by 12. Then you take the square root of all of it, okay? And the standard deviation will be 4.3. So then it says 90% of the time, the time that a person must wait falls below what value? So what does that tell us? This is asking for the 90th percentile, right? So let's draw a graph, okay? Here's a graph. We drew a graph. How cool is that? Okay, we didn't. I just copied and pasted. Okay, fine. But let's just pretend that I was cool like that. Okay, so here's our rectangle. This is our right? Our situation. So our f of x is our height. So that's still the same. That's kind of boring. So what we want to do is let's find this value k such that the area to the left of k underneath the curve is 90% of the total rectangle. Let me repeat that again. When you're finding the 90th percentile of something, in this case where you're trying to find probability and you're talking about continuous probability density functions, we're saying k, what is the value of k such that the area underneath to the left of k underneath f of x is 90% of all of it, okay? All right, so in other words, remember probability equals area. So what's the area of this rectangle? Well, that's just k times 1 over 15, or k over 15, see? That's right here. And on the left-hand side, well, the percentile is 90. It's literally the 90th percentile, so that's 0.90. So all you got to do to solve for k is multiply both sides by 15. There you go, 0.90 times 15, and your answer is 13.5. Okay. Sometimes they call k a critical value. But just to sum it up, the 90th percentile is 13.5 minutes. Okay. So 90% of the time, a person must wait at most 13.5 minutes. And that's all I have for you for 5.2. Here's your super fun homework. Good luck, and I will see you on the next video.